Okay, General Chemistry 2, this is part 2 of our integrated rate law. So we just looked at what the integrated rate law was and why we give a crap about the integrated rate law. We are going to get the most information for our money with the integrated rate law. Our goal is to be able to calculate that concentration at any given time. And we want the best data to do that. And we want the most accurate picture of that reaction. Remember, your rate changes with concentration, so we want to take that into account also. So our integrated rate law, this video, I want to give you all of the equations. And then we're going to take a separate video for each one, and we're going to calculate with each one. So let's start with zero order. What would be our actual rate law for something that's a zero order reaction? Well, this is awesome because remember our rate law, if we're going in general from A to B, our rate law would look like this. Well, if it's a zero order and I put a 0 there, well, holy cow, that just simplifies, doesn't it? That means that reactant isn't involved in your rate determining step. So it simplifies to your rate equaling your rate constant. Now, when we were to plug that in to that integrated system up in the last video, if we were to solve for an equation for that, then what we're looking at is that concentration of A at any given time. We're going to compare it to that concentration, initial concentration of A. And we would end up like this, okay? So remember, this is moles, this is your rate constant, and this is time. And this is initial. And this is at any time. This is moles. This is your rate constant. And this is your time, the time that you're solving for. Okay, awesome. Now we also commented that, well, wait a second, this is fantastic, except we may get to this from a linear plot. So I'm going to go ahead and rearrange this for you. It's the exact same expression, but I'm going to put it in terms of a linear expression. We are going to solve for both. So one of the ways that we can get to a zero rate law is if we plot it. And if our plot is linear and we get a nice straight line, then this is going to be our line equation. Isn't that awesome? Okay. Now, what would a linear plot look like with a zero order reaction? It would actually have a nice negative slope. And we're going to take a look at these. Again, we're going to plot and do all these together. But what would that picture actually look like? It would be a nice downward slope. Okay. So it would look like this. So look at this. This is kind of awesome. When we get to where we're plotting, we just kind of disappeared for a second there. When we get to where we're plotting our data points, shoot, if you can get to your slope, then you can get to your rate constant. What? So if we can take our data, let's get that to write better. And we can plot it. We can actually solve for order and rate constant just from figuring out which plot is linear. So that's what we're going to do next. That's our next set of videos. This one, I'm going to give you all of your help in your equation, and then we're going to turn right around and plot these. All right, so then for zero order, what are we actually looking at for units? Remember I said that there were 3 ways to get to this. We could get to this from the rate law. We could get to this from a plot. There you go. Number 3, units. So what are our units for that 0 order? Our units of K are going to be molarity over time. Yay. Okay, this is super fun. So pause right now. I'm writing your cheat sheet. When we discover we have a 0 order reaction, this is what we're going to solve for. So these are the equations that we're going to use. All right, let's do the same thing for first and second order, but hang on a second. I put a little trick in there. Did anybody catch it? What? Where did my moles go? Okay. Almost everywhere you read in general chemistry textbooks on integrated rate law, they skip the moles. Moles are not skipped. Moles are still in there. They are doing a simplification for you that is making your life much easier, and they're just not telling you, but they are choosing examples on purpose where your moles are 1. And that is so that in these equations, you can literally either not see A or your A is by default 1. So I just want to make that clear. A isn't disappearing. A is just going to be 1 in all of those examples that you're looking at in textbooks and in my homework and in general. But your moles are there. They're just being simplified for you. Okay, so let's go on and do the same thing for first order. What if we discover we have a first order reaction? What are our equations going to be? Well, what would our rate law look like? Awesome. Okay, so now if you have done a little bit of math, you hit pause on the last video, and just for funsies, you tried it. Let's see if we're getting to that same solution. So when you have an exponent in there now, we're going to end up with the natural log. So for our first order rate experience here, we are going to have at any time t, the natural log of those, okay? Isn't that fun? We can also have, with our natural logs, if these are flipped, so again, in any given textbook that you're looking those up, you're going to find one or the other. They're both the same. It just depends what you're solving for and how you feel like solving for that. And then what are we going to do if we want that to be linear? So what if we, again, we're going to have a plot where we're going to discover that we have a nice negative slope there. And if we rearrange these equations to give us the line equation, we are going to notice this. Okay, here is our y, mx, and b. So again, if we can get to a nice linear plot, already for us, we have our rate constant and we have our order. And our slope is going to be negative. Look, our slope is going down, which makes sense, right? That our slope is going to go down for that one. And then did you notice that our data will be different? For this one, in order to get that linear plot, we are looking at the natural log of our concentrations. So let's go back up to this one. In order to get a linear plot, we literally just have the concentration of A. But in this first order reaction, in order to see that linear plot, we actually have to take the natural log of A. So you see where we're headed. We're going to manipulate our data and look for the linear plot. All right, so let's do the same thing for second order. Let's add units. Remember, that's number 3. Let's add our units. So our units for a first order are then 1 over time. Let's not put seconds. Let's put time because it can be any time. I love it. So let's do the same thing for second order reaction. Here we are. All All right, second order reaction is super fun. Now we've got two things involved. So it could be really, we could have two different ways of a second order reaction, but I'm going to go ahead and keep it this way. So that's what our second order is going to mean. And then if you do the math on this one and you integrate, what you're going to find is now you're going to get the reciprocal. So our equation is going to look like this. Okay, I love it. And then now what if we want to rearrange that? And what we're looking for is that linear plot again. So let's do the same thing. Let's put this in a linear expression or line equation. This time, do you notice we have a positive sign there? So right here, so that means that our plot is actually going to have an upward slope. And again, our slope would be our rate constant. So there is our line equation. And then lastly, let's give us a little hint on units again. Let's hit all three. And that is this time going to be 1 over molarity times time. Remember, our units are for our K. So isn't this awesome? You can actually get to take a series of data, plot it. If you can get to a linear plot, you immediately get K and your series of equations so you can solve for concentration at any time. It's actually pretty awesome. So one of the easiest ways to solve these problems is actually to take a series of data and just plot it. So that's where we're headed next. So take this video, write these equations down. We just wrote your cheat sheet for this next exam. Remember, you need all three of these. If you have zero order, first order, second order, they're all different equations. So take this video, we just wrote your cheat sheet, and then our next video, we're going to plot each of the three and then show you how to solve some of these problems. Awesome. So we'll see you soon.